so let's go ahead and start with problem 3. We have 3x minus 8 times the quantity of 3x plus 8. This is what we call a difference of squares. So a difference of squares is just something that looks like a plus b times quantity of a minus b. You would just go ahead and distribute out, so you'd get a squared minus ab plus ab minus b squared. So then your like terms are going to cancel out in the middle, leaving you with just a squared minus b squared, otherwise known as a difference of squares. This pattern happens every single time, just refreshing for those of you who don't remember. So what's going to happen is I'm going to take my a term, which is 3x this time, and square it. So I'm going to get 9x squared. And then I'm going to have minus b squared, so 8 squared should be 64. Alright. On b, that one's what we talked about earlier, way up here. So that is that square of a difference. So I'm going to end up getting a squared minus 2ab plus b squared. So a squared would be 25y squared minus 2 times a, which is 5y, times b, which is negative 4. Excuse me, just 4. So I've already accounted for the minus sign in my expression. And then plus b squared should be 4 squared, which should be 16. So now all I gotta do is simplify this. Should take one step. So I got 25y squared minus 5 times 4 gives me 20 times 2 should give me 40. Y plus 16. And then I'm done. Alright. And C is the same thing. So I'd get a squared, which is 4x squared, minus 2ab. So I'd get 2 times a, which is 2x, times b, which is 3y. Now plus b squared, which is 3y. So I've got 9y squared after squaring that entire term. Alright, since I know how to distribute using special cases, I also need to know how to factor. So the first thing that we should always try to look for is a GCF. Do not forget that. Greatest common factor, look to see if there is a common term that goes into every single one of those individual terms. After that, there's a couple different ways that we can factor. On A, I have 2x cubed plus 2x squared minus 6x. So I notice that all of those terms are divisible by 2, and all of those terms have an x. So I'm going to divide that out, which is going to become 2x, and then I write a set of parentheses, and then I write whatever is left inside of those parentheses, because factoring is just undoing distribution. So I should have an x squared left plus an x minus a 3. Alright, from here I look to see, hey, can I factor that anymore? Yes, I can. So I get 2x on the outside still. And that factors, maybe. We'll see. So I know something times something gives me x squared, so that'd just be an x and an x leading off. And then I see, hey, can I multiply to -3 and add to +1? And the only factors of 3 that I have are 1 and 3. There's no way that I can possibly get a 1 by either adding them or subtracting them together. So, no, this one does not factor any further. So that one only factors by factoring out a GCF. The next one that I have is u cubed v plus uv cubed. So I said a lot of u's and v's in there. So I'm going to go ahead and factor out the maximum amount that they all have, not together, but individually. So I'm looking to see, okay, my first term has 3 u's, my second term has 1 u, so the maximum number of u's that I can factor out is 1. And then I have a v here and a v cubed here, so because my first term only has 1 v, I can only factor out 1 v, put a set of parentheses, write out what's left. So then I would get u squared plus v squared. Alright, and then that's about it, because that doesn't turn out to be a square of a sum. So next one, I see that my lead term is a perfect square because 25 is 5 times 5, x squared is x times x, and then 36 is also a perfect square. So I see that that's a difference of squares, so I can write 2 sets of parentheses immediately and go ahead. Like I said, I already gave you that one. It's going to be 5x to start out with. One of them's going to have a minus, one of them's going to have a plus, and then I just take the square root of that 36 as well, which is 6. Alright, so the next one is actually a difference of squares as well, because I see a minus sign between my 2 terms. Remember, terms are separated by a plus or a minus. And because this has parentheses around it, this actually counts as one big term initially. So what's going to happen is we're going to factor that just like we did. So my lead term is that 4x. So I'm going to go ahead, write my 2 sets of parentheses. What times what gives me 4x squared? Well, that would be 2x and a 2x. And then I would get a minus and a plus. Oops, I should have made these big. Let me try this again. So I get a minus and a plus, and then I get y plus 3 quantity and a y minus 3. No, plus 3 quantity, because that's inside of the parentheses. Next one, I have 9x squared plus 6x plus 1. So the first thing I notice is that my lead term is a perfect square. My last term is a perfect square, so I'm going to go back to the first page, see if that matches any of my patterns. Looking, I see I've got an a squared and a b squared with a plus sign sitting there, so I'm going to see if it is this pattern of a squared plus 2ab plus b squared. So my a in this case would be just 3x. My AB hopefully is going to be 6x, but then my B then so I'm going to see if that middle term is 2AB. So I've got 2 times A, which is 3x, times B, which is 1. Alright, so that does turn out to be that. So I can go ahead and factor this as a square of a sum. So then I'm just going to have A plus B quantity squared. So again, my A was that 3x, my B was that 1 quantity squared. Alright, on F I see that I've got 4x squared minus 12xy plus 9y squared. So again, I see my bookends are 4x squared and 9y squared. They are both perfect square numbers and perfect square variables. So I'm going to go back up, and I'm noticing that there's a minus sign this time. I'm going to see, okay, it kind of looks like this. So let's see if my middle term is negative 2ab. My a term should just be 2x. And then I get my b term should be 3y. So is my middle term negative 2ab. So I get negative 2 times a, which is 2x, times b, which is 3y. So 2 times 3 gives me 6, x times y gives me xy, and all of that times negative 2 does give me that negative 12xy. In turn, that tells me, hey, I'm going to multiply, or rewrite this as a factor, like way up here, which is going to be that a minus b quantity squared. So in this case, my a was that 2x, and minus 3y quantity squared, and you should be good to go.